Okay, this video will look at how to use the computer to create the reduced row echelon form for a given matrix. And what I'm going to do is show how you can get the matrix from the video of chapter 5.2, how you can use Wolfram Alpha, which is a great website to actually do that. So we're going to start by going to wolframalpha.com. It's a free website and it takes you to this page here. And what we want to do is get the function into reduced row echelon form, so RREF. And we're going to start by typing that in, and you see it gives you some options. And what we're going to do is start by making a bracket, and that's going to get sort of the setup of our matrix. And then we're going to put each row of our matrix into another bracket. So we start by doing the first row. We start with a bracket. And then we put in the coefficients of that matrix. So we put in our augmented matrix that we saw from the video. So in this case, that was 2. And then every time you have a new entry, you put a comma. So 2, comma 1, comma 1, comma 180. And that's the end of the first row. So we put another bracket to close it off. Comma, and we start the second row. So the second row in this case was 1, 3, 2, and then 300. Close the bracket to finish the row, and then comma, then the third row will be 2, 1, 2, 240. Close the bracket, and then we close the bracket again to say that's the end of the matrix. And we're telling now the computer that we want to do the reduced row, get the reduced row echelon form. In the book, it's called Gauss-Jordan elimination, so you can read that if you want to do it by hand, but what this is doing is Gauss-Jordan simplification in the computer. So we hit enter, it's going to compute it for us, and we see we have our reduced row echelon form down here. And we can see that we know that it's in reduced row echelon form because we have 1s down the main diagonal, 0s elsewhere, and then we know that our solutions are x is equal to 36, y is equal to 48, and z is equal to 60. And now you can use the computer, and then even here's our actual original augmented matrix. We can see that the answer down here will give us the solution to the system that we need. And this is going to work for not just 3x3 systems, but if I want to do, if I want to have a system of 4 equations, so 4 variables, 5 equations, 5 variables, so on and so forth. So Wolfram Alpha, I think, is a pretty significant, nifty tool that we can use when using, when simplifying a larger system of equations.